Hello, all. My name is Daniel Ibanez, and I'm a graduating senior here at New Mexico State University. I've been a Mark Scholar working in Dr. Teri Orr's Behavioral Ecology and Bat Organismal Physiology lab for the last 2 years. And this is the project I've been working on, where I'm studying how urbanization is related to bat presence at bridges across the Rio Grande Valley. So to get started, a bat. What is a bat? I think the average person doesn't really think about bats every day, or not as much as the people in my lab do. So here's a little background. There's about 1,400 species of bats across the world, and they share an incredible diversity of diet, for instance, where they eat blood, fruit, insects, and even nectar. So that's an incredible range of dietary habits, but also in morphology. They all look incredibly different, especially as you travel to other continents. And that leads to a lot of interesting behaviors that we see in bats. So these are the bats that we actually have here in Doña Ana County. This is a subgroup of those called the Myotis genus. They all look very similar, but they're actually pretty easy to distinguish once you know what you're looking for. These two on the right might actually look like different species, but I mean, like the same species, but they are actually different species. We also have the most common bat in the area called the Mexican free-tail bat, or Tiderida brasiliensis, and then two more big-eared bats. Here on the bottom left is the pallid bat, and on the top is a Coriorinus. Now, something special about bats is that they're very opportunistic in where they choose to roost. This includes man-made structures, as in the images seen below. And I particularly like these images because it gives you an idea of what bats would look like if they were in your attic. But it also gives you an idea for how agile these bats are and how they can fly around in tight spaces. Especially that top left image, you can see these bats are flying around, and they're going to do fine in there. And the bottom left, you see them roosting there on some wood, maybe a barn of some sorts. But we've also made some sort of attraction out of it. This is the Congress Avenue Bridge in Austin, Texas, where Mexican free-tail bats using a man-made structure as a roosting site has become a real attraction for people. And that's really cool to me, especially because it's a bridge, and that's what my project focuses on. So there is literature already out there that documents bridge use by bats in at least two bridges here in Doña Ana County. And that's pretty exciting. As you can see, there's a lot of diversity in what bridges look like here in Doña Ana County. These blue marks here indicate a major bridge that runs along the Rio Grande. And some of these images are what you might see if you got up close to them. Here in Hatch Rincon, you might see that there's an iron bridge right next to a concrete bridge. In Radium Springs, you'll see this large timber bridge. And in most of these locations like La Llorona, Lou Henson, Mesquite, Vado, Barino, and Chamberino, you have concrete bridges that all look about the same. So upon some preliminary scouting, we've located lots of bats at some of these bridges, and some of these bridges not so much. So we got curious about why bats occur at different locations. So why do bats appear at different locations? So we got to considering a few different things. The first of which is construction type. Is there going to be a difference between wood and concrete? The next is seasonality. Is there going to be a difference between the summer and the winter time? And then last, we're also thinking about urbanization. Are bats going to be common in places where there's few buildings and few people, or they're going to be more common in places where there are lots of people and lots of buildings? This led to our hypothesis. So first, we hypothesized that human population density will have an impact on the presence of bats. So first off, we're expecting to see fewer bats in locations with high human population densities. Second, we're kind of expecting that the more human tolerant species will be prevalent at these high population density bridges. So we have a secondary hypothesis, and that's just that community composition is going to change across time. So that's kind of what we're expecting, that in the summertime, when there's a lot more resources out there, that we're going to see a lot more bats. So how do we examine these questions? So what we decided to do is in August of 2020, we began monthly surveys of all the 8 bridges that we saw earlier. These were visual inspections where we were able to decide on the species composition, the location, the sex, and the quantity of each species. Around April, however, we realized that we would no longer be able to survey underneath bridges, and this is because of rising water levels. So what we decided to do was add an acoustic survey component to our study. So throughout the winter months, we had visual surveys where we could access underneath the bridge. And during summer months, when we couldn't really access the deeper parts of the bridge, where we could access the parts of the bridge that were overland, we also added acoustic surveying for those 5 months. I think it's important to get an idea of what this would actually look like, a visual survey. So we have our 8 bridges here on the bottom right corner. You can see that they're all one long line of basically I-25. So on an average surveying day, we would have 2 teams moving in different directions from campus. They would each visit 4 bridges, and bridges look pretty different between the summer and the winter. So on the far left, you can see that this is La Llorona Bridge. There's no water in it because this is a picture taken in the winter time. And on the bottom, you can see that there's a lot of water in it. And that's what makes it real difficult to actually survey in there. But if you got up close, you had your headlamp on, all your gear, this is what you might see when you got up close and actually located a few bats. Now, it's really hard to make out how many bats are in there. So we counted about 14 in that image, but it just gives you an idea of how difficult it is to actually survey these creatures. So what have we learned about bats at these bridges across Doña Ana County? First off, it was determined pretty early that we weren't going to be able to test for different construction types. And this is because only one of the bridges that we were examining is made of wood. All the rest are made of concrete. So it makes it hard to really study that. But we do have good data for seasonality and for urbanization and population density. So first, on seasonal patterns, we located about 5,320 bats from 8 species across all 8 bridges and a year of surveying. So that's pretty amazing. That's a pretty exciting number. The graph here displays the number of individuals located each month from a 2009 paper by Geluso and Mink examining 17 bridges, including 2 of our own. But in purple, as you'll see once I remove this bar, that's our data. So we're expecting it to look pretty similar. These 2 lines right here indicate the point at which water begins to flow through the river and make it real difficult to survey bridges. So in between would be when there's water, and outside of these bars would be when there's no water. So as you can see, the Geluso and Mink paper data represented by these peaks here in red, blue, and green. They look really great. In the summertime, they're seeing exactly what we expected to see, lots of bats because there's lots of resources, lots of water, lots of insects. But as you can see, our purple line here gets a little low here in the summertime. So the reason for that is actually because that was the point in which our methods diverged and we were unable to go underneath bridges to survey for bats. And instead we were relying on our acoustic data to figure out what species are there. So another way for us to think about seasonal patterns is at the individual bridge level. So that last graph really shows you what it looks like for all the data from all our bridges, but these are for 2 individual bridges. So again, we're showing individuals, except for this is for 1 bridge. So at the top here, we have Radium Springs. It's a timber bridge where there is a resident group of Mexican free-tail bats year-round. So that's represented by this high number of bats that we're seeing in the winter and summertime. So that means that they're there all the time and they only leave for only a single month period here at the end of December there. Below it, we see what we saw a lot more of at most bridges, where you saw in the winter time, there was very few bats. And in the summertime, we saw many, many bats. So we were also interested in what human population density looks like in Doña Ana County. So the way we decided to do this was to take census locations and figure out what the human population density was estimated for those regions. So this map was created in ArcGIS, and these small circles represent points of known population density for humans. And via Kriging analysis, which is basically an extrapolation of information from any variable you want, in this case, human population density, creates a heat map for what the human population density would look like in Doña Ana County. Now, you can also see the Rio Grande here, which is represented by this blue line, and 8 bridges, which are all our locations. And you can see that it's all sitting on a gradient, which is pretty great for us because we get to see what's the difference between this dark red area, which is closer to El Paso, and then the lighter red where Las Cruces is, to all the way to Hatch, where the gradient has ended and there's a lot more, or a lot less humans there. So, did we find a relationship between bat presence and human population density? So this chart here is a presence versus absence chart. We can see that there's a 1 and a 0. Basically, a 1 would represent that bats are present, and a 0 would represent no bats present. So human population density is marked on the bottom here. So what did we get? If we did see a relationship between human population density, we would have hoped to see some type of line from the bottom left corner to the top right, or top left corner to the bottom right, but instead it's all over the place. So really what this means is that we didn't find a significant relationship between human population density and bat presence. You can see that by a p-value of 0.54. So what's next? So what we want to do is find a better proxy for urbanization. We're not sure that human population density, represented here in this graph, is actually a great proxy for urbanization, but we do think that by using remote sensing, which are satellite images analyzed on ArcGIS, we might be able to get a better idea for how much urbanization is going on in a region. So the way this is done is by taking large images like this. This is taken from the Landsat satellite system, and basically zooming in until we're at the pixel level, where you just have 3 pixels here. And we will use programs such as ArcGIS to decide what constitutes a building, what constitutes vegetation, and what pixel colors constitute sand, or anything you want really. So what we're going to be doing is looking at building density and vegetation to see if we can find a relationship between our bat presence at these bridges. And really, that's what's next for this project, and it's very exciting. But it wouldn't have been possible without all these people here. So thank you to everyone in my lab and all the grants that have supported us, and especially the MARC program for supporting me for the last 2 years throughout my project. Thank you all.